Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memmis, for this episode of CompTIA Linux Plus, Troubleshooting Services Part 2. We promised it was coming. Here it is. And Don Pizzetta is also here. Don, great to see you, sir.
Glad to be back. And, we've got to wrap up our topics from the last episode. We were talking about how to identify processes that were causing us problems. We were troubleshooting some of our services, and we got a chance to see a lot of that. We looked at our processes. We got to see what it would look like if a process was acting up, but we didn't do anything about it. And that's what we're going to be tackling right here in this episode is what do we do when we see a process that is causing us problems? Can we fix the problem? Do we have to terminate the application? What is it that we can do? So there's several utilities that are baked right into your Unix and Linux systems that let you fix this stuff. And we're going to learn about quite a few of those right here in this episode.
So back to the cliffhangers. Don, what are some of the other ways we can end a process other than the top command?
All right, so in the last episode, we saw that top command. And inside a top, you can find a process acting up and you can terminate it. But sometimes a process doesn't register in an easy way inside of the top command. It's not really convenient. There are several other ways that we can kill off an application. But let me backtrack a little bit first and say killing off an application should really be your last ditch effort. You should try anything else before ending it. And the reason is if an application is running or a process is running, it might be holding open some data files. It might be in the middle of a write operation. And when you terminate the application, you can end up with corrupted data. Now, if it's just a text file you're working on, it's probably not a big deal. But if it's a SQL database or something of that nature, now you've got a real issue where you could end up with corruption. And a lot of those have transaction logs and other things that try and prevent damage, but you don't want to rely on those if you don't have to. If there's some way you can gracefully exit an application, you'll be better off. Now, I'll tell you, a lot of times people think applications are locked up. When they're not actually locked up, they're just in the background. When I first got started with Linux, it was the first true multitasking operating system that I had worked with. Because back then you had DOS and even Windows 3.1 that were really time slicers, not true multitaskers. But Linux can do more than one thing at the same time, true multitasking. And that means there's stuff that you see right in front of you, but there's stuff going on at the same time in the background. And you can actually move applications between the foreground and the background. Inside of the GUI, we don't really see that. But from the command line, you really see it quite a bit. And it happens even by accident sometimes because of some of the shortcuts. So let me show you what I mean. I'm going to go and bring up, in the last episode, I was editing a file, right? I did Vim on test.txt. So I'm editing this file. So I'm running the Vim text editor. It's running. It's got this file locked. It's doing its job. Well, when you're running, if you hit Control-Z on your keyboard, see how Vim just went away, right? Well, it didn't actually exit. It's still running. Sort of. It's moved to the stop state, but it is actually running. If I type jobs, that'll give me a list of any applications that I've put into the background. And I can see where Vim has been stuck in the background, but it's paused. And it's going to sit there paused, holding that file open forever if I leave it, right? If I want to return back to it, you see how it's got a number 1 off on the left side? The more jobs I create, the more of them kind of get stuck into the background. If I were to run nano and start typing a file and stick that one in the background. Oh, shoot. Nano maps the Control-Z. Control-Z doesn't work so well with nano. Let me show you guys a different way I should have done this. Let me get out. I will not save that. If you want to run an application to have it go right into the background, right from the very beginning, you can actually use the ampersand and stick that on there. So if I say nano ampersand, it's going to run. It's going to go right to the background like that. And if I do the jobs command, I'll now see I've got nano and I've got Vim up and running. And if I want to return to one of them, if I want to go back to nano, for example, I can just type % followed by the number of that job. So I'm going to do %2, and that'll take me back into nano. So I didn't have to kill it. I didn't have to terminate it. It was just running in the background. I just had to switch back to it. And when I park something in the background, like Vim here, see how it's in that stopped state? So I might think it's broken, it's not running. Maybe I just wanted it to run in the background. It was tying up my screen, and so I wanted to free up my screen to do other things. Well, you can use the BG command. BG is short for background. And in my case, Vim is job number 1. If I say BG1, all right, with Vim, what it does is it then starts running again. It like unpauses it. When you do Control Z, it goes in the background and it's kind of paused. And then when you say BG followed by the number, it starts it running again. Now, Vim's just going to pause again anyway because it's an interactive application. You can't be interactive when you're in the background. But if I was running MySQLD, the MySQL daemon, or MariaDB and its daemon, any kind of service, SSHD, if I was running that interactively, but then I wanted to stick it in the background, it would keep running because it's designed to run as a service, and it would just be back there kind of doing its thing, right? And you can bring something into the foreground again by using FG if you want. So if I said FG1, now I'm back into Vim. That's the same as doing percent and the number. It's just the counterpart to that BG command. So those couple of commands right there can help us to switch back into these applications that may appear locked up, but are actually just running in the background. So always check that. Just run the jobs command real quick and see if it's parked in the background.
Is there a way we can prioritize applications that are running in the background?
Yeah. So if I have 5 different applications running in the background, or 50, it doesn't matter, and one of them is consuming a bunch of resources, well, that might not be a problem. It might be okay. Look, hey, I'm encoding some videos. I expect the video encoder to consume 100% of my CPU. But that doesn't mean I have to give it 100% of my CPU. I can throttle it back and make it where it's lower priority. And that way, even though it's consuming as much CPU as it can get, I'm still able to operate my shell. I can launch Firefox and do other things because I've deprioritized that activity. And that's another one where if an application is spiking and consuming 100% of your CPU, you don't necessarily have to kill it right away. You can change its priority. And in the Unix world, priority is measured by what's called a niceness value. It's kind of a funny one. It's how nice the program is. And think about the old days in the schoolyard. What do nice kids do? Nice kids share. Well, in the Unix world, we can share too. By default, every application is treated equally. They're all assigned a niceness value of 10. And just 10 is the number that's assigned, and everybody's the same. And the only person who gets any real priority is the kernel. Everybody else just kind of runs and competes for resources, right? But I can tweak that. The nice values actually range from -20 all the way to +19. And this is one of those scenarios where a bigger number is not better. So 19 is the slowest. A +19 is the slowest. And a -20 is the fastest, all right? And it's hard to kind of, the human mind wants to look at it a different way. Like if I'm on the interstate and I hit my gas pedal, a higher number means I'm going faster. But think of niceness as setting a penalty, right? So a positive number is a bigger penalty. A negative number is like a reward at that point. So if I were to give something a niceness value of 20, first off, it would be a bad idea. But secondly, it would become the highest priority job on that system. I mean, it would really crank the resources. Nobody else could compete with it. With a value of -20, it's so prioritized that I will likely lock up my system. Nothing else is going to be able to respond. That one application has just total priority. So we have to be careful. We don't normally assign negative values. We don't normally increase something's priority. We normally decrease it. If I have something that's running at 100% CPU, I could give it a higher niceness value, and that's going to slow it down. And I shouldn't say slow it down. As long as the CPU is available, it's going to use it at regular speed. But if somebody else asks for access to the CPU, they'll get it because they have a better priority or a better niceness value than the other application. And the way we can do this is there's a few ways. We can do it right when we run an application. So when I ran Vim, instead of just running Vim and calling it a day, I could have said nice -n and then specified a value. Now, 10 is the default, so maybe I give it a value of 11, right? I don't want to penalize it too much, but anybody who's got a nice value of 10 should get priority over this guy who will have a nice value of 11. And then I can run Vim on my, test.txt file. Now I'm in Vim and I'm working. Things look normal, right? I can come in and I can add more lines and do all that other great stuff. This is another line. Woo, awesome. And it works like normal. But at the same time, in the background is being prioritized differently. And when we go into utilities like top, and you're looking, see this column here. I think I skipped over this in the last episode. This column that says NI, right? That's the niceness value. And you can look down the line, and there's a couple of -20s that are in there, like the K worker. That's the kernel worker. The kernel's got to be able to do its job, so it gets a -20 on stuff. Almost everything that has a -20 is tied to the kernel in some way or another. But other applications will have a different value. And I said my default value was 10. It looks like on this system it's actually 0. I think I lied to everybody. Let me switch. I'm just going to view my user account. It certainly is. My default value happens to be 0. And, oh, no, I see what it's doing. See how my niceness value down here for, well, Pulse Audio has got a negative 11. I'm seeing all sorts of different stuff. Well, anyhow, so normally the default is 10, and I've set mine to jump to 11. And that is going to make it penalized. And I don't see Vim up here because it doesn't consume a lot of CPU, but you can view that niceness value here. When I start an application, using that nice command is pretty easy. Oop, I'm in the wrong tab. There. Using that is easy. But what if I want to change the value after it's already running, right? So I did this one, nice-n 11. But if the application is running already, I don't want to stop it. I want it to keep doing what it's doing. I just want to lower its priority. So what you can do is you can leave that application running, and in another tab, or you could stick it in the background, either way, you can use the renice command. Renice changes the priority of a running application. Now, in order to use renice, you have to know the process ID. You can't use the application name. With nice, I just use nice and then Vim because I'm telling it the command to run. But with renice, there might be more than one copy of Vim running. How does it know which one I want to do? So I'm going to do a PS. There's actually a few different ways we can find a process ID, but I'll just use PS. And I will filter that, and I'm going to look for Vim. And there we go. And I can see that it's process ID 14735. So I can do a renice -n and specify a number. I'm going to renice it to 12. And then that process ID, in my case, 14735. And once I do that, now it says the old priority was 11, new priority is 12. So it's been updated, and now it's different. The program didn't close. The program is still running. So right back over here, I'm still in it. I can still come in here and add another line. Everything's working like normal. It just has a different priority. So that's always a better option to terminating an application, because once we've kind of changed its priority, our system should return back to normal. And now we can go in and troubleshoot. Like, why is it at 100% CPU? Is it okay? Or is there a problem? I can go look at my log files and try and track that down. But meanwhile, the program is still running. And that's usually a lot safer.
So if all that fails, Don, is it Hulk smash time?
Absolutely.
Hulk smash.
There does come a time where brute force becomes the right solution.
You feel that way sometimes, don't you? You know you have.
All right, so let's say that I'm done with it. Vim is causing me too many problems. I need to get it closed out, and it's time to smash it. And so we can kill it. I showed the top command in the last episode. That's not the easiest way to kill things. Mainly, I need to find the process ID. Okay. Now, a moment ago, I found the process ID by using PSaux and piped it into grep. Most distros actually have a shortcut for that. And the shortcut is pgrep. And what pgrep does is it runs PSaux and it filters it through grep. So it's kind of an alias that wraps it all together. And so I can do pgrep and then just type vim, and it's going to look through my processes and show me all the process IDs that are tied to an application named Vim. And so there it is, 14735. Much faster, a little bit easier to remember. So pgrep helps me find it. Once I've found it, I can kill it off. Now, there's two ways that I want to show you to kill off an application. One is just using the kill command. If I know that application just has a single process, and I know the process ID, I can do kill 14735, and that's going to kill it off. All right, and that ends it. If it's my process, I can do it like I just did right here. If it's another user's process, I'll have to sudo this. I'll have to have administrative privileges to do it. But at this point, I've killed it off. If I go to my other tab, I can see that Vim exited, right? It says, caught deadly signal term. It was sent a terminate signal, and it preserved files and finished. That's good, right? So it tried to save things for me, and then it fixed itself. In fact, if I run Vim again, it didn't do it this time. A lot of times it'll actually mention that you have a temporary file, and it'll offer to recover it for you, but it did not do that for me. Oh, here we go. If I try and edit it now, it's saying it spotted that file, and it's offering to recover the changes that I didn't save. So I have that chance, and I can open it up read-only. I can edit it. I can recover it. I'm going to hit R to recover, and there I am. I'm back in my file, and I hadn't saved it since I typed that other line, so it actually recovered it. It's a nice way to be able to get back in there. Sometimes, though, it's a little more complex, and Firefox is a great example of that one. When I launched Firefox, it has more than one process tied to it. It had all those child processes. And that leads to a challenge that if I want to terminate it and it's stuck, I might terminate the parent and the child processes stay running. Or there might be more than one copy of Firefox and I want to terminate all of that. So in those scenarios, there's another command we can use that's a little more aggressive. and it's the kill all command. Now, we don't run kill all by itself because that sounds crazy. Like we'd kill all our processes, we'd get logged out, right? But if you type kill all and then the name of an application, it's going to look for any process with that name and terminate it. Now, if I'm running 3 copies of Firefox, it's going to terminate all 3 and their associated child processes. So it's going to try and knock all those out. So I've got, let me get Firefox maximized here in the background. And when I run that kill all Firefox, there it goes. It finds it, locates that process and the other processes that are named the same way and terminates them out. So another easy way to get in there and just wipe those processes out.
Well done, sir. As usual, Troubleshooting Services Part 2. I have enjoyed it. Hopefully you saw Part 1, and if you didn't, please do. Before we move on, Don, anything else?
All right. When you terminate a process like this, you kind of solve the immediate symptom, but you haven't actually solved the problem, right? You still need to go and find out why was that application misbehaving. And for that, we need log files, which we're going to be looking at in another episode. Unix and Linux keep extensive logging data, and we can sift through and hopefully try and locate what that problem is. But a lot of times, you're going to end up going to your software vendor and saying, your application is misbehaving. I don't know why. Help me figure it out. And they kind of walk you through that.
Fantastic. Thank you, Don. And always keep learning. CompTIA Linux Plus is a fabulous series. Don's done a great job putting this together for you. Information you can use now and in the future, and there's supplementary information as well in our course library that will help you do one thing, be even more successful. So check that out too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.